students, today we're going to look at how we can solve two-step linear equations in one variable. But before we do that, let's look at some important vocabulary. As you can see here, we have an equation right here. We know it's an equation because it has an equal sign. So far we have been learning about expressions when we used our formulas for surface area and volume, and we evaluated the expressions in the last unit. Now we're going to be focusing on equations. So the first vocabulary word we're going to look at is variable. The variable is the x value that we have right here. A variable is a letter used to represent a number. It's an unknown value. If we don't know what it is, we use a letter called a variable to represent it. The next thing we're going to look at is the word coefficient. The coefficient is the number that's next to the variable. And when you have a number next to a variable, it means you're going to multiply. So the coefficient is a number used to multiply a variable. We also, you can see we have an operator. So the operator is an operation sign. It can be addition, it can be subtraction, multiplication, or division. And the last word we're going to define is constant. A constant, as you can see these two numbers, 7 and 5, they do not have variables next to them, and they are numbers that are on their own. They're within the equation, but they don't have any variables next to them, and they're on their own. Now that we've looked at the vocabulary, let's take a look at two equations and solve them together. So the steps for solving an equation is we're going to undo the addition or subtraction, and then we're going to undo the multiplication or division. Now when we have these basic equations, that is the order we're going to follow. But sometimes, you'll see in some other examples, sometimes we will undo the multiplication or division first, but it depends on how it's written. So let's take a look. Oh, and we're going to also check. We're going to check using our Desmos calculator. So here's our first example. And with an equation, our goal is to get the variable by itself. We're trying to isolate the variable. So let's go ahead and organize our work here. So I like to put a line between each of the sides of the equation so that when I work on one side, I know I'm doing the same on the other. So what I'm doing is I'm undoing what has been done to my variable. So I have my variable here, which is c, and I'm trying to get c by itself. In this equation, I see that c has been multiplied by 6, and we've also added 8 to it to get 50. So I'm going to work backwards to try to figure out what the variable is. So I'm going to subtract 8. I'm going to undo the addition that was done. I'm going to subtract 8. If I do it to one side, I must do it to the other. Once I subtract the 8, I have 6c remaining over here. I just bring that down because I haven't undone the multiplication yet. And then on the other side, 50 minus 8 is 42. Now what I have, I've isolated part of the variable, but I still have 6c. I want 1c. And as we looked before, when we have a coefficient next to a variable, that means multiply. So I'm going to undo multiplication by dividing. So I'm going to divide both sides by the number I multiplied by. Again, I'm trying to get c by itself, so I'm working backwards to undo what was done. When you have 6 divided by 6, you get 1. So if I undo multiplication by dividing by 6, it means I'm getting back to 1c because I'm dividing 6 by 6. So I'm going to go ahead and put that here for now. So 6 divided by 6 is 1, so I have 1c. And then 42 divided by 6 is 7. I've isolated my variable. It does say 1, but when I have 1c, what I really have is just c. So my answer here is going to be 7. Now we're going to look at how we check it, both with and without the Desmos calculator. So I'm going to put in, I have my equation over here, and I'm going to put in 6, and then I got c. I already know what c is. It's 7 plus 8, and I want to see if that's equal to 50. So 6 times 7, I'm going to do this first, right? Because when I'm solving an expression or evaluating expressions, I solve using the order of operations. 6 times 7 is 42. I do multiplication before I do addition. 42 plus 8 is 50. And I have 50 on the other side, so I can check. It is correct. I can also do this using my calculator. So go ahead and open up your Desmos calculator and try this along with me. So I'm going to do the same thing. Using my Desmos. So what I'm going to do is I'm going to put in the expression part, because what I'm trying to see is if c is equal to 7, would I get 50? Because if I do, I know that I solved the equation correctly. So I'm going to put in 6c. I'm just putting this part in of the expression, or of the equation, plus 8, okay? I'm not going to put in equals 50. I want to know if what I did by getting c equals 7 will give me 50, because if it does, I know I'm correct. So I'm going to go to my next line, and I'm going to tell Desmos, check for 7. So I'm going to put in c equals 7. And look, because I got 50, right? I put in the expression, I put in c equals 7, I got 50, just like I had here in my original equation. So I know that it's correct. Now if I put something else like 7, let's say I accidentally, I get a negative 7. Now notice if I put in negative 7, that's not the right answer. I don't get 50 over here. So let's go back and put the correct answer. Okay, let's try our second equation. So I'm going to scroll down. All right. This time I have the variable on the right. It doesn't matter. We're just going to we're going to work on the right and then do the same thing on the left. So this time I have a variable d that's been divided by -5, and then 8 has been added to it. So let's think about this in terms of the order of operations. We have grouping, exponents, multiplication or division, whichever comes first, addition or subtraction. So what I'm doing is I'm looking at what has been done to the variable. I have d, it's been divided, okay? So it's been divided, so I'm going to circle division here. And I've also added a number. I've added 8. So that's going to help me determine what I'm going to do to solve it and in what order. So I'm doing backwards GEMDAS. So first thing I'm going to do is I'm going to undo this addition here. How do I undo addition? By the inverse, which is subtraction. So I'm going to subtract 8 from both sides. Okay? So on the right side, 8 minus 8 is 0. So I can just cancel that out. I don't need to bring it down because it's just 0. I am going to bring down what I have left in my equation, which is d divided by negative 5. Okay, now we have to look at the other side. 11 minus 8. 11 minus 8 is 3. So right now I have 3 is equal to d divided by negative 5. So I undid my addition with subtraction. Now I'm going to undo my division. I undo division with multiplication. And I'm going to multiply by the same number I divided by, because if I multiply by the same number I divided by, I get back to d. So I'm going to multiply both sides by negative 5. So when I divide by negative 5 and then I multiply by negative 5, that is going to be equal to 1, just like the last problem. So I just have d over 1, which is d. So I have d on this side. And then I'm going to simplify negative 5 times 3, which is negative 15. And notice I did undo the division up here. Because I divided by a negative, I also had to multiply by a negative to undo it. So I undid my division by multiplication. And now I have my answer. Next step, we're going to look at checking. So 11 equals, okay, my d value is negative. Remember, I'm just going to plug that in. I have d here. I know that d from the equation that we solved is negative 15. So I have negative 15 divided by negative 5 plus 8. And so I'm just going to go through. I already have 11. That's simplified on the left. I need to simplify what I have on the right. Negative 15 divided by negative 5. Okay, if we needed to use a calculator, we could do that. So negative 15 divided by negative 5, you get 3. And if you wanted the negative sign to be up there with the 15, you can, but you would get the same answer. So I'm going to go ahead and make it look just like the problem. Negative 15 divided by negative 5 is positive 3. So now I get 11. Negative 15 divided by negative 5 is 3 plus 8. And I'm trying to see if what I have on the right matches what I have on the left. So I'm just going to bring down the 11. 3 plus 8 is 11. So check. We solved it correctly. Now, just like in the last example, we're also going to look at how we can check using the Desmos calculator. So I'm going to bring that in next. And I'm going to put in this part here. If you guys take a look, this part of our equation, not the 11. We want to see if what we got for d will give us 11. So I'm going to put in d divided by, I'm going to use the subtraction key because it's minus 5 or negative 5. D divided by negative 5 plus 8. Okay, now notice it doesn't tell us anything. We need to tell it what is d. What did we get for d? And we're going to put d in and see if it's correct. So I'm going to go to the next line and I'm going to tell Desmos that we got d equals 15. Now take a look. We're trying to see if we can get 11, right? I got 5. I wonder if that means I solved my equation wrong, or maybe I forgot to do something else. See if you notice that. What I forgot to do was put in that negative sign. So I'm going to put in negative and see if I get that 11. And I do. So I have, look here, I have the same thing that I have on the top line. I just have the variable on a different side. It doesn't matter. So this is the same. I put in d equals negative 15. I got 11. So it checks. Okay, now you've seen a few examples in solving two-step equations, and you're going to try some more practice in class.